Max NG7M here, back for part 8 of my video series on how to assemble and build, calibrate a RF kit, B26-RF2K plus amplifier. And I actually made a version of this video a week ago or so. I can't remember now. Work and life gets in the way there a little bit. But I decided to pull that because I just wasn't comfortable with the outcome of that video. And between then and now, I have a much better understanding. I've spent a fair amount of time talking to Reinhardt, who really is the designer and creator of this amplifier, about a number of questions that I had. And so this video reflects what I've learned since then. As far as the high power calibration is concerned, I haven't found a concise guide because this is a work in progress, right? It's a kit amplifier, and I'm sure that'll improve. So keep that in mind. This is a reference as of September 2nd. You can see here on the screen here, and things will change. Documentation will change. So the responsibility is on you to spend time in the forum, the RF Kit forum, and get to know the amplifier if you decide to buy one of these and set it up and calibrate it. Just make sure you're looking at all the latest information and ask questions, because obviously I can't be held responsible, right, if you screw something up. I have no pecuniary interest as they say in the amplifier. I'm just, I've been having a good time building it, putting it together, calibrating it, and then learning along the way. So with that, for this video, and again, Reinhardt, DH3NAB, I always credit him. Obviously, he's the best source here, and the other gents that are involved with the project, Canute, the software design, and I know Chris, DL5NAM, is involved with the website, and I've heard rumblings that a new website is very close, by the way, if not out there already. I haven't looked for a while. And then another expert of this amplifier is Mark, NU6X. So he's worked on some of the documentation too. So it's a kit amplifier, right? It's amateur radio, so don't get your undies all twisted around an axle here if everything isn't perfect, like, from a multi-million-dollar manufacturer. It's an amazing piece of gear, and a lot of technology and a lot of potential. So that's my shameless plug here for the amplifier. In this video, I actually made notes this time, because this I think is probably the most critical step as far as actually getting to the stage where you're going to use the amplifier, go have fun in some contests, and really kick the tires on the amplifier. And so during this video, I'll keep me out of the way, put me down in that lower left-hand corner where I belong, I should say. And let's see, it looks like I was making some adjustments there. But I'm going to pull up a document I put together, and this is my document here. Let's see. And I'm going to refer to this, and I'm not even sure if you can be able to see this super well on the screen there. I'll make it big. And this is my documentation. I haven't, it's just based upon a culmination of talking to Reinhardt, gleaning information off the forums, exchanging some email with some other guys. So I'll leave that up on the left side just to give me a plan to go on. You notice in my other videos it's pretty ad hoc. I'm just kind of rambling along, going through the information, but this is critical. So I threw this document together, and we'll see if I put this on the website. For now, we'll see how the reception is as far as this video goes, and we'll go from there. On the other side, though, I'm going to reference the images I have on my photo gallery, which this has had a lot of traffic, so we'll use these images here. But for now, we're going to kind of go through this document. So repeating myself a little bit. Oh, and by the way, you can see my little friend here. Here's my amplifier. I did send out a link to all the pictures of the powder-coated case, and I'll do another video after this one where I go through my musings and commentary on using the W4YN front panel and the powder coating and countersinking the screws and all that stuff. So, lucky you guys, you got another video after this one if you haven't had enough of me yet. But let's talk about the document I have here. Just to repeat, I'm not going to be responsible if you screw something up, right? The LD-MOS devices, they don't give them away, right? Amplion, I think, is the company. They don't give that stuff away just quite yet. And the quote here I wanted to mention, and I don't mean to be too harsh here, but stupid is as stupid does, from Forrest Gump. For those in, the English-speaking world, I'm sure you know about the movie Forrest Gump. Stupid is as stupid does, and that includes me, right? So if I've made mistakes here, if I've got something wrong, that's on me. It's not going to be on you. You've got to figure it out, though. So I'm belaboring that fact, but I'm not going to be held responsible if you screw something up on your, $3,800 US at the time I made this video amplifier, give or take a few $100. So there's a couple things I wanted to make a note of right here, and it relates to the transmit delay supported by this amplifier. Early on, I assumed that like an 8 millisecond transmit delay, because I'm a Elecraft fanboy. I've got a K3S here that I've been driving it with, and by default, its PTT to exciter input, right, if you're driving an amplifier, is 8 milliseconds. So from the time the PTT closes, the K3S, in my case, will delay 8 seconds by default, and then it'll pump RF on the output. After talking to Reinhardt and my own experiments using my LP700, where I can look at the CW trace, it was clear that the way that the RF2K Plus is programmed is it's very conservative, making sure that there's no hot RF switching. So the QRO, or the high power relay on the amplifier, is switched first, and then the low power relay is switched, and then depending on if you're in cat mode, there is a longer check to make sure the amplifier is on the right frequency with a built-in frequency counter. That's another plug for using cat, because I believe that delay is less if you're using cat control. So the programming is not quite as aggressive there if you're using cat, because it's going to assume that the amplifier is right on the frequency. But anyway, to make a long story short there, based on my experiments, you need to set your TX delay on your driving transceiver or exciter to around 15 milliseconds. So that's what I have mine set up right now. And I haven't seen any hot switching, but the problem you'll see if your transmit delay is lower than probably around 12 or 13 seconds actually. I put 15 milliseconds here just to be, the relays are going to all vary a little bit different. But the relays that were installed as of the time I took shipment of my amplifier, early August 2018, are rated around, I think, 13 to 15 milliseconds, somewhere around there. So if you were a CW guy like me, I mean, I do SSB, but mostly digital stuff, RTTY and CW is my favorite mode to operate. You have the equipment to test and look at the CW trace output. You'll see what is happening is the high power relay and the low power relays will be closed, but then if your exciter puts RF into the amplifier before the frequency check is done and before the bias is enabled in the amplifier, which is going to give you the output, you'll see a little leading tail on your CW trace. And so by setting your TX delay to at least 15 milliseconds, you're not going to see that. So, and I may show some CW traces here in a bit during this video. So that's note number one. If you're a slow CW guy and you want to do full QSK, so the point is if this is not designed right now and set up and programmed, the controller, the B26 controller is not designed for QRQ or is fast. QRQ is fast CW. Full QSK. You can do it at lower speeds, but you'll quickly see once you have your transmit delay higher, like 15 milliseconds, that the relays are just going to start to float as soon as you turn up the CW speed in full QSK. All right, so I think I've covered that. Number one. Note number two. Note number two, there's been a lot of discussion on the forum about the forward power meter drift, in particular on the amplifier, right? Okay, and once I got the case on, once I got everything calibrated, I was happy. I was aware of that, but let me just kind of read through my note number two here. So the forward power meter drift. What I've seen is lower output will be displayed on the amplifier, right? If you're VNC'd in or on the front of the amplifier, until things warm up beyond like a cooler room temperature. For example, this morning it was pretty cool down here in my shack, around 65 degrees Fahrenheit. And I noticed that the output power was much lower than the actual output power on my reference meter. In this case, it's an LP700. But as the amplifier warmed up, the meters became closer because most of my calibration was done when the amplifier was warmed up. So it's a known issue as of the date of this document. Don't expect the forward power meter on the amp to be accurate until the amplifier is warmed up with the case on, because you're going to have more heat retained in the case, and so that SWR bridge, which I think that's where the drift is happening from what I've read based upon other guys on the forum. And for high power operating, stupid is as stupid does, right? Always use a good external forward and reflected SWR power meter that you have a known reference. Don't assume that the meter on the amplifier is like the reference you should be using. I never do that. Even on, I have a $7,000 SPE 2K FA. I don't trust the meter on it, right? I've got a Tokyo High Power. Same thing. I'm just not going to trust the meters on the amplifiers. I'm going to base the power output on what I'm seeing on an external reference meter. So I think some changes will probably be made, and Reinhardt will work out some issues on the drift there. But for now, use a good external meter. And when in doubt here, see the quote from above. Stupid is as stupid does. So those are the two big points I wanted to make before we get into talking about kind of the meat of the QRO or high power calibration. All right, so this video assumes that you have completed the calibration steps with the RF palette bypass. So there's no chance of RF exciting the RF palette. So this video goes through having removed the bypass, and now we have exciter output potential exciting the RF palette. And I want to talk about a couple pots on the controller and on the RF palette before we get into what I have deemed as, for me, the best way to calibrate the QRO output and meters on the amplifier. So I'm going to come over here. Now we're going to talk about this window right here, and specifically R1 down here. R1 is used, you'll find, we'll talk about it more later, but I just wanted to kind of call out R1 and then another pot I was not aware of. So R1 is used to set the drive level protection. So if you're over driving the amp, protection that will kick the amp out of operate into standby and give you an error where you're driving the amplifier with too much drive input. And that's, of course, is based upon you calibrating the amplifier properly. And so that is R1 right down here. You can see my cursor going around right there. And counterclockwise, in the case of this particular pot, will allow for more RF drive. Clockwise will allow for less RF drive, and you'll kick the amp into protection mode quicker if you twist that knob clockwise. So it's backwards, right? If you want more drive without going to protected mode, you go counterclockwise, and if you want less drive, you go clockwise. The other picture I wanted to talk about, or pot rather, is on the RF deck. So looking from the front of the amplifier right here, look at my cursor, I was told it's R219 in the schematic. I'm pretty sure I got that right. So I was having trouble getting legal limit output, which is 1.5 kW here in the US, across the bands until I adjusted this pot right here, R219, which I'll talk about later. And I had a good Skype discussion video chat with Reinhardt on this, and he assumed I was aware of this pot, which I was not. It's not referenced that I remember, but maybe I missed it in some of the previous calibration documents. So for me to get full legal limit out, on all the bands except 6 meters, because I know you're going to only get about 500-600 watts there. You may need to increase the current draw limit of the RF deck. So the power supply, the switching power supply in the amplifier, I believe is rated at up to like 55 amps at 53 volts, which that's a lot of current. And this pot just simply will keep the controller from airing, going into a protected state when you're drawing X amount of amperage from the power supply. So in all my testing at the QRO levels, I haven't seen the power supply or the RF deck draw more than maybe 48 amps. I think that was pushing it. 48 amps in my case. Yours will vary a little bit, right? But you will use R219 if you struggle with getting full legal limit out, if you're wanting to make sure you get 1.5 kW out of the amplifier across the bands. You may need to turn this pot clockwise to allow for more current, counterclockwise to allow for less current before it goes into a protected state, kicks out of standby into a protected air state. So in my case, I'm just off the top of my head, I think I ended up giving this pot like 2 or 3 clockwise turns. So there you go. R219, and I'll probably touch on that later. So back to my document here. I think I touched on all this. Clockwise means more amperage, counterclockwise means less. It's opposite of R1. And I'll be showing you near, really close to 1.5 kW here, which may be a little bit more depending on the accuracy of my meter across the bands, especially the contest bands. I didn't get too hell-bent on the work bands on getting 1.5 kW, but it's very close. Excluding 6 meters. The little commentary on that. Fast forward if you get tired of me yapping. But in the picture here too, the design of the transformer on the RF deck it takes a lot of current, right? The transformer going through this thing. There is a 470 picofarad RF, high Q, high RF voltage rated capacitor here. And on my experience on 15 meters and 6 meters, you're going to heat this baby up. So be careful with the constant carrier testing you're doing on especially 15 meters, 21 megahertz, or 6 meters, 50 megahertz. And I'm perfectly fine right now with the output on 6 meters around 600 watts if you push it. Just don't get crazy pushing the drive beyond where the amplifier is linear. It's silly in any amplifier, and especially a solid state amplifier, in my opinion. So just talking about that. As you're doing the calibration, another caveat or disclaimer, be very careful right here. You're dealing with high voltage, high current in this amplifier, and in the wrong hands, that high current could kill you. So, end of story. Stupid is as stupid does, right? It's a kit amplifier. You're expected to not be stupid. So be safe, be careful. All right, let's do this. I'm just going to go back to let's see here. Let's get to the next steps that I'm going to talk about. And I'm not going to show like a close-up of the amplifier, but I will have the VNC screen output up here shortly. What I've done after you've completed the adjustments, the final adjustments I made before considering things ready to roll, I broke down into 5 steps, and I've labeled them here A, B, C, D, and E. And you revisit the actual steps in the current documentation. So we'll revisit step 11, 12, 13, and then I'll revisit on step 9 down into 2 parts. So let's actually do something here. I'm going to pull up VNC. So here's the front of the amplifier. I'm going to go to let's see here. I actually have 1mm running there. It just popped up. So I'm going to go to 20 meters, and step A here I have is revisiting step 11 in the manual, which by the way I have, no, I don't have it up here, so you'll have to reference that yourself. Step 11 in the calibration manual is where you calibrate the low-pass filter for power protection. So there's sensors on the controller that detect a variance in the input and output of the low-pass filter, right? What goes in and what comes out should be close. Those are some complex impedances there on the filters, I assume. So it gets a little tricky there. So step 11, based upon reviewing posts in the forum, some guys have been getting and myself included, we're getting a low pass filter mismatch protection errors on usually the higher bands, if I remember right. Once I got above 15 meters, like 24 megahertz. And so step 11, you'll want to and Reinhardt actually recommended this in a post, and it seems to have been working great for me. So I'm going to key the amplifier here, and we'll pull up, see if I can get the VNC on the screen. I'll just bring this over here so you can see my document, I guess. And so I'm on 14 megahertz right now. You can see 14.84 because I'm using cat control. And I'm going to key the amplifier. And let's see here. Oh, wait a minute. After I put it in operate. Okay. I'm just going to key the amplifier. And I'm going to give a little juice here. And so right about 500 watts drive. There. 500 watts drive. That was funny on, did you notice down here that the output power didn't show correct there? That was interesting. So I unkeyed and keyed it back up. So you can see right now the fans just kicked on too. So the RF deck is at 45 degrees C down here. Hopefully you can see that cursor. I think you can down here. And as that warms up, you're going to lose a little power output. So at 500 watts drive, right, we should be fine for a fairly long key down. So I'm up to 51 degrees C here. That's pretty warm in the shack today too. So back to A. We're just going to go make sure you're on the right band, everything's correct, you're in operate. We're going to go to the menu, and we're going to go to the debug tab right here, and we're going to be looking at A2, which is the power PA module out setting, and we're going to, at 500 watts, we're going to adjust that to 400 using R17. I've already adjusted this, so I'm not going to do any adjusting. So it's R17, right? R17, which is right here, right there. Okay. So I'm going to key the amplifier back up, and you'll see that now A2 has, it's showing 31 there, and as I increase the power, that's going to go up, and so that should be around 400 right as I hit 500 watts output drive on the amplifier. I doubt you're going to hear the fan, but the fan just slowed down. See, so I'm right at 500 watts out according to my LP700, and you can see that that's right around 400 right there. So R17, adjust that to be right around 400. I believe in the original manual it was higher, but I'm reducing that somewhat. Will keep those low-pass filter errors from happening based upon comments from Reinhardt. All right, so that's step A there, okay, that I wanted to talk about. Okay, step 12 here. We're going to revisit step 12 in the original manual, the combined manual that was out as of the time of this video. And what we're going to do here is we're going to go down to 1.9 megahertz, 160 meters, and I'm going to determine the max drive level from my K3S, my exciter, to achieve 1.5 kW output, because that band is the band that requires the highest level output. And I want to determine how many watts drive, and I think it's around 70 watts drive with a 13 dB attenuator installed. And then what you do is you will adjust R1 to cause a protection fault just beyond that max drive. So hopefully I'm explaining this well. It's the upper threshold of what's the max drive I would ever want to put into the amplifier, which requires you to do this on the band that requires the most drive, which also gives you the potential to overdrive those other bands. So be careful, right? So this is just me. This made sense to me. So I'm going to go down to 160 meters. That might pop up N1MM again because I'm switching bands here. And it did. I'm actually just going to shut down N1MM. I'm going to use that to show some RTTY, driving it with RTTY, so you get some reference as to the temperature under like a contest scenario. So I'm down on 1.9 megahertz. You can see right here, and I'm actually going to key the amplifier, right? And I'm going to drive it up to 1.5 kW output. So driving the amplifier up here, you can see the LP700. As I drive the amplifier up, you're going to see a jump as the K3S kicks into its second amplifier right here at 13 watts, right there. And so I'm driving it up, driving it up, driving it up to, and it stops becoming linear. Oh, right there. See, so you can actually, I wanted to drive it up there to where I had R1 set. So I've unkeyed the amplifier, and so you'll notice down here, input power too high, press reset. So I'm going to reset the amplifier, and it goes back to standby. But I'm going to leave it in standby, and now I want to show you, I'm in CW, I want to show you how much drive level I had. So I was right around 70 watts. So if I go back to operate, and I key the amplifier, I'm going to speed up the CW a little bit here. So now I'm keying in a semi-break-in. And I can show you the input here. If I go to channel 1 on my LP700. So I'm right at 70 watts. And as soon as I drove the amplifier beyond that 70 watts, I had adjusted R1 to create that threshold for me. So as soon as the input drive gets to right at that 1.5 kW on the band that requires the most drive, 160 meters, it kicks into protected state. So let's do it again. So I'm going to drive the amp up now. Oh, wait a minute. Let's make sure we're good and reset here. Oh, wait a minute, I'm all confused here. Rightly so, I don't have my meter on channel 2, which is the high output. Or I could put it on, I could also put it on auto. So channel 2, let's just put it on auto, and then it'll pick the highest output channel. Sorry, got a little confused there. So here, we'll drive the amplifier up now. You should see it trip right as I approach 1500 watts drive out. Okay, just kicked in separate amplifier, and it's going to air out real quick here. Boom, just aired out. I unkeyed the exciter, input power too high. Reset, and leave it in standby. So again, R1, right? R1 right there. I went counterclockwise to allow for more drive power. Okay, so that 70 watts will be, I'll reference that a little later on. So back to step B here. We just calibrated the input power protection on the band that requires the most drive. This makes sense to me. It may not make sense to others. It makes sense to me. And I described that there. So that's actual, a successful calibration behavior. Let's go to step 3 here. Oh yeah. So I determined that about 70 watts, right, in revisiting step 12 here, which I'm calling B. So here, step 13 in the calibration manual, using the drive level determined in the previous step right here, which was 70 watts, I'm going to adjust the relative input power bar. That's the bar. I'm going to come over here. That's this bar right here that I'm circling here. It's green with the gray on both ends. And that's a relative bar that shows you the input power. And I wanted it relative to the band that required the highest drive, right? So this bar should be maxed out yellow when I hit 70 watts. Okay, so when I'm on 20 meters and it only requires, 22 watts of drive, you're going to see that only 20% of the input power has been reached to achieve 1.5 kW out on 20 meters or 80 meters or whatever, right? I wanted it relative to the band that required the most input drive. So in step 13, you will, using the drive level determined in the previous step, which is 70 watts, adjust the relative power input bar, the bar under the forward power meter on the standard screen 1 or 2, to where the yellow color fills the gray area. This should be the power level just before the amp trips input power protection on the band that requires the most drive. So what the heck, let's do it again. I'm going to go back into operate here, and I'm going to drive it up. Now we're going to look at this little bar. See the yellow bar right here? And that should max out right as I trip into the power protection. So right as you see that max out, actually it went a little further, right? So I might need to tweak that, but it's good enough for me. So that is that step. I unkeyed the exciter, and so now we're done with step 13. Okay, step D right here. I did this, so this is a revisiting of the calibrate the SWR bridge, which is step 9 in the manual. And the first part of that step, you adjust the coupling capacitor that is right by the directional coupler to the left of the SWR bridge. And here, I can show you a picture of that. It's right here. So this is we're going to dip the SWR using this pot right here, okay? So the easiest way I found to do this was the manual shows that you use A5 on the debug screen right here, or excuse me, A5, power output reflected, which I found to get a good dip on that. I just realized this today. I find it much easier, and I'm going to go up to 10 meters. That's following the original manual. Recommends doing 10 meters or 6 meters. I found it easier to tweak the SWR, dip the SWR right here using that pot with this meter rather than the debug screen. So that's just me. I got a better dip because it was kind of flickering around in the other one. So and I did it at QRO levels, like 300 to 500 watts. So I came in, keyed the amplifier. I'm on 10 megahertz. I drove the amplifier up to 500 watts here, and don't expect to see a perfect 1-to-1 SWR, even though you're attached to a 1-to-1 high power load, right? And so you'll then dip this meter, and that's about as low as I could get it. It was like 1.22 to 1 here on 10 meters. And so you just need to consider the low pass filters there, and their impedance now is in the mix. So I wanted to do it at high power, so the low pass filter was in the mix, and just so I dipped that SWR setting to its lowest value with a quality QRO dummy load attached with RF going through those low pass filters. So we're almost done here. That was number D, number 4. So that's the first part where we revisit step number 9. We're going to complete the whole kit and caboodle here by, now this has caused a lot of discussion on the forum too, where you're trying to make the forward power display on the amplifier match reality. This is where the drift comes in too. So you want to do this when things are warmed up on the amplifier. And I've been pretty successful. It's taken some trial and error, because once you get back into the SWR bridge, the having the shielding on the SWR bridge and the cover on the amplifier will impact things a little bit. So I mean, if you're kind of anal like I am and want to get it pretty close, I think I did it on 20 meters, so 14 megahertz. So let's see how accurate I am. This is kind of live on the demo. We've heated up the amp. The RF deck's at 41 degrees centigrade. And so again, step 9, after the amp is warmed up in the SWR bridge shielded box, adjust forward power pot to match a good reference forward power meter at about 1 kW, okay? And here's a big hot tip. Don't keep the amp keyed down forever at 1.5 kW, right? I mean, it's just common sense. You don't want to heat this thing up, to where it's going to hit the temperature protection. Counterclockwise, this is not CW as in continuous wave. Clockwise will decrease the output. You'll see here on the screen, right here under the forward power. I hope you're seeing my cursor there. And counterclockwise will increase it, so it's backwards, right? If you need to increase what's displayed to match your reference meter, you need to go counterclockwise. If you need to decrease to match your reference meter, you need to go clockwise. So I've already made the adjustment. I'm tired of opening up the amplifier and tweaking that. So let's, we've warmed up the amp a little bit here. Let's see how accurate you are. If we're within 100, 200 watts, I'll be happy. So I'm on 14 megahertz. I'm going to key the amplifier where it operates. And so up here you're seeing my reference meter. And so at 400 watts, pretty close, right? We're in the ballpark for 64. Yeah, actually, as the amplifier warms up, you'll see my experience has been that this has gone up. I mentioned that earlier. So if we get up to a kW here on 14 megahertz, right, pretty darn close. So, and that's going to vary. It's tough to accurately measure RF at these levels without spending a fortune. So I'm going to unkey that. I believe I'm getting right around legal limit output on 20 meters, around 13 watts drive. And I think there's a little overshoot on my exciter. So you'll see the drive power potentially go up here. I'm going to key some CW now. So yeah, so right at about 13 watts out there, we're getting legal limit out. So if I go back to channel 1 here, see, so yeah, so right around 13 watts on 20 meters with a 13 dB attenuator, I'm getting right around 1.5 kW output. So that covers the discussion on the meter, and I thought I would go through and kind of give you a demo of full legal output here across the bands. And let's do that sending some constant carrier RTTY, and we can call this good. So I'm going to go down to 1.9 megahertz. Of course, I'm in a dummy load here. I'm going to move this over here, and I'm going to bring up N1MM. I'll just use it to do the RTTY. And there's one other reason I wanted to bring up N1MM here. And just want to make sure we can see all the windows. I want to show you with the cat enabled right over here. So changing bands, I've noticed this is kind of specific to a K3. Changing bands on the K3, there seems to be a little delay on the front of the panel. If you change bands using N1MM, the sampling of the B26 controller Seems to be about a half-second faster. I know some guys were asking how fast will the amplifier switch bands. So if you watch down here, I'm on 1.9 megahertz there. Let me open up a contest that is like RTTY here. NAQP, just a low power contest. I'm just going to use it to get some RF output on RTTY. We'll do it at QRL. But I wanted to show you, in N1MM you can change bands, right, by typing in the frequency. Like if I wanted to go to 80 meters, you just type in 3500 and it'll change it. So keep an eye over here. So it just switched, the amplifier just switched to 80 meters. You can also use control up, control down, and it'll switch between the contest bands, the 5 contest bands. So if I go back to 180, you can hear me click the page up, page down, and then you can see over here how long it takes the amplifier to detect that change via the cat control. So here so if I, jump up to 14 megahertz, actually I did 2 bands there. So I hit the page up twice. So if I go down, so there's 14 megahertz, 21 megahertz. So that gives you an idea of how long it takes the amplifier to switch based upon the cat control. Okay, enough of that. All right, so let's drive the amplifier with some constant carrier, like you're calling CQ in an RTTY contest right here. So I'm down on 160 meters, and I have about 69, 70 watts drive for full output, as we saw in those earlier steps. And I need to get on the right channel here. Just put it on the auto channel. Okay, we're in operate. Everything's ready to roll. So here we're calling CQ. I think I have about a 3.2 second delay here, just to kind of give you constant carrier mode guys a reference here. Just under 1.5 kW. It could be a little over because the margin of error on the meter. So the amplifier RF deck here on 160 meters is at 47 centigrade. And if I take it out of operate, you'll see how much drive. About 70 watts drive on 160 meters. Okay, I'm going to kick it up to the next contest band, which is 80 meters. We're going to do the same thing. Go to operate. So here we're just over 1.5 kW and less than 70 watts drive here. And if you're an RTTY operator, you love the diddle going on there. And to show you how much power drive that required, it's about 42 watts. So makes sense, right, with that 13 dB attenuator on the input. So that was 80 meters. So now we're going to go up to 40 meters. Do the same thing. Back and operate. And I'll show you. So here we're just over 1.5 kW on 40 meters. You can see how much amperage is being drawn down here on the display. So right about 43 amps at 53 volts there. Amplifier still below 50 C, which is really good, and it's very quiet. This is the quietest solid state amplifier I have ever owned, and this is the 4th one. So it's very quiet. And I have, oh, by the way, I have the fans on the higher level. I have them on the 15 volt output level. So there we've called CQ, driven the RF palette up to 50 degrees centigrade there about. And that was with 37, 38 watts drive. Okay. All right, let's go up to the next band. So now we're up to 20 meters. So I'll do a little call CQ here. And got the channel auto. And I'm not seeing output here. What's going on here? Channel 2. Oh, I know what's wrong. I don't think the transceiver's in data mode. Let me switch. Make sure it's in RTTY mode. Okay. Yeah. So that was a K3 thing. No, I'm still not. What am I doing here? I've got something. I've got something funky on. I think it's It's either an N1MM thing or my. Because when I key the amplifier, it's fine. That might be an N1MM thing, guys. Here, let me. I'm just going to show you via CW. That's nothing to do with the amplifier. So I'm going to go to CW here on the amplifier. So again, with about 13. I'm getting some overshoot there, but and I only noticed that on 20 meters on the K3. And you know, maybe I need to check with Elecraft on that, but you can see here with 13 watts drive, I'm getting legal limit out. You know, 12, 13 watts. I'm going to pull up N1MM there again. See if that resolved. Should go to RTTY. Okay. Yeah, that was something funky there. Go back and operate. So there you go. 1.5 kW out with 13 watts in with the 13 dB attenuator. So that just tells you what those two of those LD MOSFETs can do, you know, depending on the frequency. So anyway, a little digression there. N1MM and K3S thing. Let's go up to the next band, and we'll be on 15 meters, 21 megahertz, and let's see what we get here. So here, driving the amplifier, you can see the relative input. I'd guess we're right around 30 watts or something down here. Just calling CQ. As a reminder, 15 meters and 6 meters seem to heat up the RF palette transformer the most by far. So just, if you're going to be doing a lot of constant carrier stuff, don't get too crazy on those bands. So there may be some design changes, I'm guessing, in that transformer. Who knows? We'll see what Reinhardt comes up with. So back up to 50C, calling CQ there. And let me just go back to auto here. We're going to go to standby to see how much drive we were using. So 21 watts here on 21 megahertz, 15 meters to get full legal limit out. So pretty sweet, huh? And I didn't look at the amperage there, but we can take a peek at that again. Go back to operate. So right around 45 amps being drawn from the power supply there. All right, next band, and we'll be up on 28 megahertz, 10 meters. We're just going to go for it. I'm in data mode. So here, again, right at 1.5 kW. Calling CQ, we're drawing just under 43 amps down here. And it's humming along like a well-oiled machine. So here, let me give you, so that kind of shows you legal limit out across the bands. We'll quickly go through the other bands here on CW, and including 6 meters, and kind of round that out, and then we'll call this video good. I'm going to shut down N1MM for that. Let's go down to 5.3 megahertz here. I've got, and I'm not going to push these other bands here. I've got it in CW, dummy load, of course. So that is with It's 5.3 megahertz, 60 meter band. That's with 13 watts drive. You're seeing 1200 watts out. I could easily push that. I'm not going to. Let's go up to 10 megahertz, which I have never transmitted more than 200 watts out on 10 megahertz in the US because that's the legal limit. But in a dummy load, I have. So, okay, so I'm in CW here on 10 megahertz, and it looks like I have about 30 watts drive here. So 30 watts, 34 watts is starting to push 1.5 kW on 30 meters. We can see how much drive I had there. Let's go to standby. So about 34 watts, give or take a few there. Let's go to the next work band. Up to 18 megahertz, I have about 16 watts drive, it looks like right now, looking at the front of the K3S. So I'm getting close to 1.4 kW, and I can go up to around 19 watts. So they're pushing 1500 watts there, easy, with 18 watts drive. Okay, next work band, 24.9 megahertz. Looks like I'm at about 20 watts drive back into operate on CW. Getting the meters settling in there right around 1400 watts. Shaving a haircut, 2 bits there. If I push it a little bit, again, no need to. There we go, just above 1500 watts with around 24 watts drive. Not too shabby. Okay, I think we get one more band. Well, yeah, because that was 24 megahertz. And let's go up to 6 meters. And I am not going to push it here because right around 500 to 600 watts, it stops being linear. And so currently I have it at, leave it in standby here, I should be right around 60 watts. So 63 watts. Put it in operate. So with 60, what was it, 60 watts there, right around, I'm just above 500 watts out. If I push it up to 70 watts, right, I should get close to the input protection level there. So if I push it a little bit more, there was 600 watts. There you go, guys. Back to my document here. I think you're done, and I've noticed Reinhardt has this comment at the end of the calibration. Have fun using your amp, or go use your amp. I mean, I've spent way too much time over the last 3 or 4 weeks tweaking on this amplifier. I'm tired of doing that. I want to start kicking the tires, and I'll likely maybe do a video on CW of a CWT or maybe a high-speed CW contest and show the amplifier operating for real, or maybe an RTTY contest. But I hope you enjoyed that, and I hope you have good luck with your RF2K Plus amplifier. I will be making another video to go through the completion of the case where I had the powder coating done from a local guy, and it's beautiful to me. I mean, it looks great. The front panel, I keep giving shameless plugs to Tim. Whiskey 4 Yankee November W4YN. Shoot an email off to Tim and work out getting one of those front panels. I think it's a must-have, and I think you can do different colors too. So I just wanted to go with the Henry Ford Model T. You can have any color you want as long as it's black, and so that's what I did. 73 guys, and good luck. Be careful, be safe, don't do anything stupid, because stupid is as stupid does. 73 for now. Bye.